Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 10. Sam wants to generate 10 millivolt of EMF by moving a wire at 5 meter per second through a steady magnetic field region of 0.06 Tesla. What should be the angle between the magnetic field and direction of motion so that the wire can be of shortest length? So it is a question of motional EMF, and we know that EMF induced E, it is given by BLV. And in this formula, V is the perpendicular component of the velocity, the component of velocity that is perpendicular to the magnetic field. So it's better to write V perpendicular. So the complete formula will become BLV sine theta. Now, we need to find the angle between the magnetic field B and the velocity vector V such that L is minimum. So L is equal to E divided by B V sine theta. And from this equation, we know that the value of EMF is fixed. It is given to us. Value of B is also fixed, 0.06 Tesla. And value of V is given to us as 5 meter per second. They all are constants. Now the only value that will decide whether L will be minimum or maximum, that is sine theta. And we can see that L is inversely proportional to sine theta. So this implies that L will be minimum when sine theta is maximum. So more with the value of sine theta, less with the value of L. And we all know that the maximum value that sine theta can achieve is 1. So it ranges from -1 to 1. So that's why the maximum value of sine theta can be 1. And this implies theta should be equal to sine inverse of 1. That has to be equal to 90 degree or pi by 2. So this means this thing, that when the angle between B vector and V vector is 90, then length of wire will be minimum. So part A is completed. The angle between the magnetic field and the direction of motion has to be 90 degree. Now part B says, what should this shortest length of the wire be? So we need to find the length L when the angle between magnetic field vector and velocity vector is 90 degree. So the situation, it can be visualized like this, that this is the wire and it has been moved in this magnetic field region perpendicular to field B. And the objective is to generate 10 millivolt EMF. And we already know that sine theta has to be equal to 1 because angle theta is 90 degree. So EMF is given to us as 10 millivolt. That is equal to 10 multiplied by 10 to the power minus 3 volt. So let's put the values of B and V perpendicular in this equation. So we will be using L is equal to E divided by VB. That will be equal to 10 multiplied by 10 to the power minus 3 divided by 6 into 10 to the power minus 2. Because this magnetic field, it is 0.06 and we can write it as 6 multiplied by 10 to the power minus 2 Tesla. And the value of B, it was given to us as 5 meter per second. So this will be cancelled out with this and we are left with 10 to the power minus 1. This cancelled out with this and we are left with 1 by 30. So it is equal to 1 by 30 meters. And when we convert it to centimeter, we have to multiply it with 100. So L will be equal to 100 by 30 centimeter. That will be equal to 3.33 centimeter. So this is the final answer. The shortest length of the wire that is required to generate 10 millivolt of EMF when it is passed perpendicularly through a magnetic field of 0.06 Tesla, it has to be 3.33 centimeter. Thank you. Keep learning, keep practicing, keep excelling.